All right, chapter 6, standard deviation and the normal model.
He's an old soul. You prepare.
Yeah, I keep saying okay.
Like, okay.
To compare unlike data, we standardize data using z-scores. The formula for that is z is equal to y minus y bar over s. And I'm sure your follow-up question is, what does all that mean? Y is the data value. Y bar is the mean of the distribution. And S is the standard deviation. A z-score tells us how many standard deviations a value is from the mean of the distribution. A positive z-value is above the mean. A negative z-value is below the mean. The larger the value of the z-score, the more unusual a value is. Now, when it says the larger the z-score, that really should be like the absolute value of it, because a negative like 4K z-score is very unusual. Okay.
Like, just negatives in general are unusual for z-scores?
No. Typically we say more than 3 in either direction. If we're like standard. So it just depends, but I was just using that as an example. The farther away it goes in either direction, the more unusual it is. All right, ready for an example? We're already done with one page, though, if that makes you feel any better.
Oh,
Oh.
it actually does, because that one took like...
The mean score,
An example's part of the pages?
yes, on a test is 72. The standard deviation of scores is 4 points. Fenwick
I'm sorry.
gets an 82. What is the z-score for his test? So, a mean score of 72. That is y bar. Okay, the variable with the bar over it is the mean. The standard deviation of 4 is S. Fenwick gets an 82, so that's the actual value, so that's y. And we want to know what the z-score for his test is. So z is equal to the actual, that's y, so 82, minus the mean, so that's 72, over standard deviation, which is 4. Now, I am going to tell you the formula for z-score. You need to have that memorized.
We've had to memorize worse.
There will be worse that you memorize this year, but I'm just letting you know now. You have to know it.
What is one of them? Like the worst.
It's like in chapter like 24 or something. It's like, it's just long.
We gotta waste a while.
I mean, yes.
So this is 10 over 4 or 2.5. So the conclusion for that is that Fenwick's score is 2.5 standard deviations above the mean. So good job, Fenwick.
I've never met a Fenwick, but
Probably never will.
I'm sure he's never met a Nathan. He probably lives in like
I don't know.
So then a follow-up to this, Fenwick's friend,
What's his friend's name?
Chris,
No way.
says his test score has a z-value. Okay, z-value, z-score get used interchangeably. They're the same thing. Just, anyways. Of negative 0.5. What score did Chris get? Now, if y'all start telling each other what you got on a test based on a z-score,
You'll think we've lost it,
yeah.
which will not be too
Peyton's gonna
bad.
be like, I got a 2 above.
Standard deviation.
I got 2.5.
I got a z-score of 2. I'm gonna be like, you might as well just say you're great. Like,
I mean,
So
how would
what's-
we know what the
what's
mean of the scores was?
so we're trying to find, well, if I tell you the mean, you would know. So we're trying to find y now for Chris. Okay, we're trying to find what his actual score was. So we basically take the formula and we manipulate it. So we plug in the z-value, so negative 0.5 is equal to y minus 72, still the mean, over the standard deviation of 4. 4 times 0.5 is, well, negative is negative 2. Y minus 72. Add 72. So he got a 70.
Yeah, could have just said that in the first place.
Guys, I literally just finished writing down the problem.
So,
I think he was just hopeful that Fenwick wouldn't know how to find what the actual
Yeah.
score was.
what's the real life application?
That if Josh tells you his grade and his Z-score, you can figure out what it was.
Great. That's gonna take me places.
Then another follow-up question.
You know, I'm done with these follow-ups.
Whose test is more remarkable?
Remarkable?
Like better?
Yeah.
Okay.
Well, not Chris.
I mean, if Chris did really, really bad, then that would be pretty remarkable.
I mean, if you do really bad,
Right.
that's kinda
Because in a
remarkable.
sense, when they say remarkable, they're meaning unusual.
Yeah.
But
It was still
Wait.
it would still be
it
the
would
same
still
answer.
be Fenwick.
Fenwick, because his Z-score is farther from 0 than Chris's. Okay, so that's why I said earlier, to be unusual, it's like distance from 0, so you kind of have to think of it more like absolute value.
Nice.
Guys, I got a 3.1.
Guys,
Well.
what do you think? What do you think the average was on the available quizzes?
I don't know. I got a 14. out of
Negative
15.
0.75.
Because I'm about to find out.
Probably.
I'm about to find out my Z-score on my available quiz.
Wait, I want to do that too.
All
I
right.
think everyone will give us their scores so we can find the mean.
I got a 61.
Oof.
All right.
You didn't fail it.
When you shift data,
Here's like, I didn't do good either.
the center
No one
moves,
did good.
but the spread stays the
We've
same.
all done that before.
It was
It's
so
okay.
uncomfortable.
I'm sorry.
Rescaling data changes the center and the spread.
Not me questioning if I spelled the word you right.
What did you?
I did,
Yeah, I
but
got
it
it.
looks wrong.
Guys, page 2's done.
Nice.
You ever just look at a word for
I got a
wrong
remarkable
and it just
score.
seems like it's spelled wrong?
I think that I was trying to write the word you once and I forgot the you.
Yo.
That took my brain a second to understand. Rescaling. Dude.
Why are you reading that loud?
Because I was like, I don't know.
All right, a normal model.
Is
This is kind of like the start of a new like topic within the notes. If you're like,
Oh, thank you.
Thank you. Because
if you're like trying to follow. A normal model is a way to make assumptions about our distribution based on the shape of the distribution. A normal distribution is unimodal and symmetric, roughly. Oh gosh, that was not good. That was not good. And it looks roughly like that. It's a bell curve.
Beautiful drawing.
Gorgeous. 10 out of
It's supposed to be like a perfect little hill, but
Mine's definitely not perfect.
mine is definitely not
I
either.
like those.
Wow.
They're fun.
Can we just take a little break second so it can catch up?
Just be better, Josh.
What?
Yeah, Josh.
I just need
Josh said
a
he
little
needs a break
second to
second.
catch up.
Shouldn't have been so distracted.
A little
And you shouldn't have had so much attitude.
Why is Smooches like stuck under your desk?
Because she wants to abuse him.
No, I was like hiding.
Because she's a terrible parent.
I'm not a terrible parent. I'm a great parent.
Then love him
I
properly.
do love him.
Properly.
Yeah, there's a right and wrong way to love.
Did you find out?
Huh?
What?
What, Nathan?
There's a wrong and a right way to love. That's what he said. Right?
Yes.
The wrong one.
Yeah.
I was like,
Have you ever like heard of abuse?
But that's not love.
Some people do see it as love.
Yeah, but it's like the wrong way to love.
Exactly. Just stop. Don't make the sloth do that.
Okay, what the heck?
Are we
I
good
got
now?
Peanut butter crumbs on him.
Peanut butter crumbs.
Sorry.
All right. It is named
Sorry.
Oh.
based on its mean and standard deviation. Because it's a model, we use mu for the mean and sigma
I
for
did not draw you right.
standard deviation.
That's also the abbreviation for micro.
Y'all learned something in physics.
What is that?
Thanks
So,
for stealing my
Mu.
thought.
how do I draw that?
A cursive U with a tail.
cursive
But like the tail comes first.
sigma.
But yeah, the tail's at the beginning.
So cursive U with a front tail.
So like,
What is
So
doesn't have to be that obnoxious, but
Oh,
Are you
okay.
thinking that?
What's so funny? Sigma. So sigma just like a sideways 6.
yes, basically.
I didn't even think about that.
Now I know what that thing is on the calculator.
Wait,
I was
where?
trying to
Where's
figure
that?
out- No,
I got
no.
peanut butter
I
on
was
my
trying to figure
calculator.
out, like, for standard deviation, what it was, and I had to look it up, and that was what it showed for like what standard
my
deviation.
sigma looks like alfalfa.
What?
These two numbers,
Say, you mean like.
okay, mu and sigma are numbers, are the parameters of the model. All right.
Yes, from our little restaurant.
This right here is how we symbolize the normal model and tell what the mean and standard deviation are.
How we what the model?
Huh?
Indicate. How we indicate.
Oh, I was like,
So
It's finally starting to get cool.
Yes, finally.
the air, not the math.
I like how you had to clarify that, but we pretty sure all of us understood.
I know, but I still have to clarify.
Saying.
It's really nice that it's getting cooler.
I can't imagine running at like 90-degree heat. Like, I don't want to run in general. Like,
I mean, it's not the most pleasant, but I can do it. I'd rather not have to.
The Z calculation
Cross country should be a winter sport.
for a normal model looks like Z is equal to Y minus mu over sigma. Which the good news is, this is exactly the same way we calculate for any distribution. Page 3 down.
Wow, that was so fast.
my page too.
What time is class?
17 more minutes.
I don't think we're getting.
No, we're not.
Okay.
The standard normal model is written as N01. We use this model when we have standardized our values to Z values.
Just remembered I have to make dinner tonight.
What?
I have to make dinner tonight.
What are you making?
I thought I
Yeah.
heard something.
You always make pancakes when you make dinner.
Because
Do you know how
I
to
make them good.
Like, do you never make anything else?
My mom
Shit.
wanted me to make pancakes.
I'm really good at French toast.
Yes, I know how to
Whoa.
make a lot of things. Whoa.
I'm making mean peanut butter jelly sandwich.
I know how to make a lot of things, but my mom always wants me to make
What
pancakes.
is the thing under the very important, or is the thing above?
What's about to come under it?
I think the very important is very
And it's like a couple lines.
Oh, I think the very important should take a couple of lines to make it really stick out.
On my paper, it's 7, but I wrote really big because I was writing in a thick Sharpie, so it's probably not actually 7 lines. All right,
A lot of space.
the very important. You must verify that the data meets the nearly normal conditions before you use normal models. Check these conditions. By making a histogram. And verifying that it is unimodal and symmetric. Be sure to write that you checked the conditions. The next thing is the empirical rule, and you're going to probably want enough room for like at least 10 lines because there's going to be a drawing that goes with this.
Thanks for that, Zach.
Good thing I just started a new page.
Okay, let's talk. The empirical formula, isn't this
I
like
spelled
the
empirical
reduced?
wrong.
Wait, did we learn this?
Wait,
this is
chemistry?
Marshall, the empirical formula is like the reduced version of it.
I spelled empirical with an I.
Or I might just be going crazy.
No, wait, no,
It's the
no.
68, 95, 99.7 rule.
It's not this, but
There
I
might be
definitely know what
something.
you're talking
No,
about.
I don't.
There is
know
an
that.
empirical rule in chemistry as well.
But that's what the empirical rule is?
Huh?
That's what the empirical rule is in chemistry?
No. I'm saying
Oh,
there
I was
is
like-
one for chemistry.
I was
That's
like,
the-
wait,
the
it's not
width
remember.
went one.
I find it really funny that I started writing really neatly after the very important.
In a standard normal model,
I'm just intruding, don't mind me.
Okay. We used to Emily intruding.
68%
I'll teach you.
of the data falls within plus or minus 1 standard deviation from the mean. %95 is within plus or minus 2 standard deviations. And 99.7% is within plus or minus 3 standard deviations. And I'm sure you're wondering about the other 0.3%, and that's just beyond that. And I've mentioned this before, but anytime you see me just write SD, that means standard deviation. 'Cause I don't write it out.
Yeah.
Pretty much beyond this chapter, I very rarely write it out. All right, so drawing a normal curve, that's going to follow this empirical rule. That's why I said you'd want to have room for it. All right, so we have your as close to normal looking curve as possible. You think as many times as I've drawn
That's okay.
these, like I could make them, huh? We're not done.
Oh,
There's stuff that's going under it. We're doing like a little example beside it.
okay.
Is
What were
this
you
the part
saying?
that would take 10 lines?
Well, not done.
From
Not done.
here down to.
Oh, okay.
We're putting stuff under it.
Okay.
Don't worry, it's not the same thing.
All right, so we start at 0, and then it goes out to 3 on each side. So I'm doing it generically on this one. I'm going to do one to a specific example in just a second. That's going to be beside it so you can see what I'm talking about. So, based on this empirical rule, what this says is that between -1 and 1, okay, standard deviations away, 68% of our data is here. Two standard deviations away, 95% of our data is here. And then 3 standard deviations away, 99.7% of our data is there.
Okay.
All right, and then we're going to stop after the example because I'm not going to get into the next thing. I'd rather pick that up tomorrow. All right, so that was generic, so based on a specific model. So we're going to do it for n of 30 and 5. Okay, so that means that our mean is 30, standard deviation is 5, and this is for fuel efficiency, which is in miles per gallon. That one looks a little better than the last one. So our mean is 30. So this middle point here is 30. Then we add 5 going to the right until we're out 3 standard deviations. So we'll have 35, 40, and 45. Then the other way we subtract 5. So 25, 20, and 15. So 68% of our data is between 25 and 35. %, is between 20 and 40. And 99.7 is between 15 and 45. I keep reading them backwards. So in words, we can write statements such as for this specific example, approximately 95% of all cars will have gas mileage between 20 and 40 miles per gallon. So we're gonna stop there for right now. Tomorrow we're gonna look at normal percentiles, percentiles to scores, and stuff like that. So there's gonna be some stuff on our calculator that we're gonna be looking at. If we don't actually look at it on the calculator tomorrow, then on Monday on the examples we'll look at it. We're about halfway through the notes.